All right, so first one we're going to look at below is a table containing the number of calories per serving for 16 brands of frozen cheese pizza. Find the 5-number summary for the list above. Remember the 5-number summary is Q0, Q1, Q2, Q3, Q4. What's the best way to do this? Calculator. How do we do it on the calculator, Joey? So you enter all your data in. I've already got mine all entered into L1. It's all just one data set.
Oh.
I'm not copying the table, I'm just entering the data. So it's all wherever you want to put it. I put mine in L1. Oh yeah.
Every single number.
It's all the same data set though.
Oh, they're all.
Right? It's all just one data set. It's all measuring the same thing. It's only in columns because you can't literally fit all those numbers in a row on a sheet of paper. You know what I mean? Once I get in there, good. Stat again. What do I do once I'm in stat? Calc. Then what? One var stats. And we'll do that with our list. I put mine in L1. No frequency list needed. Thank you. And we hit calculate. Scroll down to the bottom there. You should see the numbers for the 5-figure summary. Min is Q0. Q1 is listed. Median is Q2. Q3 is listed. Max is Q4. Those last 5 numbers are your 5-number summary. Q0, Q1, Q2, Q3, Q4. So min is Q0. Median is Q2. Max is Q4. Q1 and Q3 are listed and labeled as such on the calculator. Those are your 5-number summary. What does the Q stand for? Quartiles. So the first quartile means that measurement is bigger than exactly 25% of the data. The median means it's bigger than exactly 50% of the data, exactly half, etc., etc. Everybody's cool?
So, I'm confused. The Q's are the min, Q1, median, Q3, max.
Yeah. Yeah. Boy, that's easy with the calculator, right? If you had to do this by hand, you'd have to order your stuff from biggest to largest, figure out the median of the left-hand side and the right-hand side. It's a giant hassle. You don't want to have to do it.
So 5-number summary is just median, mean, mode, and then.
No, it's Q0, Q1, Q2, Q3, and Q4.
So,
Those are the 5 numbers.
Yeah.
They're those bottom 5 numbers on your calculator.
how would you write that, like on a test? Like,
Q0 equals 260. Q1 equals 315. Q2 equals 330. Q3 equals 345. Q4 equals 380. That's all.
So Q0 is minimum, Q1 is 3. Okay.
Yup. All right. Another one. Do this one. 5-number summary for the data. there's the answer, so you can check as you go. Make sure you're practicing today with your calculator. I would estimate about 75% of this class is just do you know how to get the answer to come out of your calculator. Which Nate's going, all right. Guess I need to make sure I know how to do this. The good news is it's not too hard. But you need some practice kind of walking through the menus and doing it over and over and over again. Livy, you okay? You're making some faces. Okay. Just checking. I saw some like eyes bug out there for a second. I want to make sure. Tori, you okay? Okay. Okay. Next one. Hey, do you recognize this data? It's that pizza data again. What are we asking for this time, though?
Mean.
The mean. So you could add them all up and divide by 16, right? Or, yeah, I do the same thing. I just do the one var stats on it. Oh, no, you did? I should have told you to save it.
Yeah, it's fine.
Who remembers the symbol for mean?
X bar.
Yeah, X bar, the X with the line on top of it. So that's just the first number listed in my one variable stats, 328.75. You guys are doing good, remembering all the symbols and stuff. Add away. Looking at those PowerPoints again or something. Or maybe just like dialing in the first time. That's what I got right up there. I loaded all the data in previous to class starting, so I'm just like ready to rip.
Can I go to that?
Sure. Take a look at the next one. Uh-oh. What do we have here? We have a frequency table. How many lists am I going to need here? 2. I'm going to need 1 for the measurement and 1 for the frequencies. When you do your one variable stats, you're going to have to enter a frequency list. Make sure when you run your one variable stats, you enter a frequency list. Wherever you typed in the frequencies, that's where that list goes. If you do it correctly, 2.8 is our answer. Bam! How nice is that, right? I love the calculator. Like, all I got to do is make sure the data's in there, and I don't have to worry about like goofing up, typing something else in, or like remembering the formulas. The calculator will handle it for me, especially like the silly like counting stuff. Like medians and quartiles in practice are kind of a hassle to come up with. Because if the data is not sorted biggest to smallest or something, it's like, it's really time consuming to like take 20 data points and make sure you have them listed in the right order. And you didn't forget one. Ugh.
So like on the ACT or something, if we're asked to find the mean, median, and mode, we could just type it into like a table like this.
Oh, heck yeah.
Do that.
Yeah, absolutely. Especially in that situation where it's a multiple choice. Nobody wants to see your work.
What's the mode?
Most frequently occurring, right? Let's look at the next one.
So what's the most?
The mode, we'll talk about how to do that in a second.
Oh,
What do I do with this one? Yeah, what's that called though? Mid-interval value. Yeah, since my measurements are given as a class, like 65 to 69, I need to use the mid-interval value there. What's the mid-interval value for 65 to 69? Just 67, right? Halfway, 2 from each end, right? What's the one for 70 to 74? 72, etc., right? When in doubt, you could add them up and divide by 2, but, I mean, these are probably easy enough that you can eyeball it. But if you don't trust yourself, so you should get like 86.375.
how do we answer that?
Use the mid-interval value.
Oh. You just had two. Thanks, Laura. No, I'm just saying. Aren't you understanding?
All right. What if we give them to you as your classes look like this? Does it change anything? What do I do here?
Like 11.
Yeah, still use the mid-interval value. So 11.5, 12.5, 13.5, etc.
Yeah.
So 14. And no, they started handing out popcorn in the potty. That's, I don't know if I take it. You can get poop corn instead of popcorn. That was a good one, Mr. Kulik. Because I just added 1 O.
That's so funny. Is this?
Yeah. Yeah.
14.
You just do a mid-interval value. That's what I got.
Yay!
So 11.5, 12.5, 13.5, etc.
GDC.
Graphic Display Calculator. That's that thing on your thumb. Yeah. But it's different than like,
Why did it say calculator?
because it's different than like this, which is like a 4-function scientific calculator.
Didn't last year you give Reese that for some exam she had?
Probably.
Yeah.
That sounds right. I think she needed like a 4-function calculator for econ or something.
Oh,
yeah,
we had
yeah.
to use that.
I have to run all over the school because I need to report on stuff.
But you really didn't, probably.
I didn't.
Yeah.
Why did we, on the test, we were just right? It's not that right. That's the mean.
Yep. All right. So let's go back now to examples 3 through 6. We're going to find the mode or modal class. So if I go back to example 3, what was the mode here?
I have no idea.
Unfortunately, you have to just do this by hand.
What?
modes.
Is it the one that has the most?
Yeah, it's just the most frequently occurring.
320?
How many times does 320 occur?
3,
How about 340? How many times does that occur?
2, 3, 3.
So what does that tell you then?
It's 340 and 320.
Yeah, there are two mode for that one, 320 and 340. They both occur 3 times. You don't average them. They're just listed separately. It just has 2 mode. It's fine. Bimodal, yeah, you could say that. That's a word for sure.
Is it actually?
Yeah. Yep.
Psych is having it.
Yeah, it is. Way to go, Mr. Smith. All right. Example 4. What's the mode for this one? Three is correct. Why is it 3? Because it happens 7 times, and 7's the highest frequency. Easy peasy, right? We love frequency tables for modes, because all you gotta do is look at the frequencies. You don't have to go searching and counting how many times something happens. Somebody's already done that for you, which we say thank you very much for saving me the time. How about for number 5? Well, that's not the answer.
Wait, I'm confused.
You'd say 90 to 94 would be the modal class. So because we don't have the raw numbers, all we know is there were 6 observations between 90 and 94.
So like the biggest frequency.
Yeah. So
What's that for?
we're still talking about modes. This is just called a modal class because if I look at the observation, it's a grouped observation instead of just like a single, right? The previous one was just like 3 books. This one is you got between 90 and 94 or something.
So you would write modal classes 90 to 90.
Yes, absolutely. I'm excited.
Really?
Yeah, aren't you?
Yeah, I'm so pumped.
Good. How about 6?
15 and 6. Why? Oh, 13 and 14.
Yeah, 13 to 14 is our modal class again, because it's a ranged data rather than a discrete amount. Everybody feel good about that? All right. Below is a table containing the amount of fat in grams for 9 different McDonald's fish and chicken sandwiches. Mr. Kulik, did you have to talk about McDonald's sandwiches right before lunch on a mass day where it's like,
Fish, that's disgusting.
all right. Alaskan pollock is delightful. It's okay.
But like, just because
Has anyone ever had a fish fillet?
Yeah,
Are they good?
No.
they're pretty good.
I feel like I would not trust fish from McDonald's.
Yeah,
It's
like a
deep.
fish stick,
It's
but like-
yeah. It's just it's like a fish stick.
I don't eat fish.
That's all it is.
Fried
It's like a big fish. It's a big square fish stick.
fried fish.
Yeah,
Like a
It's like fish
I
and
think I would
chips.
just
yeah.
like salmon, but honestly,
It's pollock instead of cod. Cod is your standard fish and chips.
Salmon
But-
and like.
So Pacific whitefish.
I thought it was actually chips. It's potatoes.
It's fries.
Or fries. I thought
English call French fries chips.
Yeah, so whenever like someone order, I'm like, oh, where's your chips?
Oh,
I'm like,
no,
what?
no, I like.
Like it's this French fry right here. All right. First one says make a well-labeled stem plot for the information
I
above.
don't even know what that is.
What are the numbers that I need in my stem?
0, 1, 2, 3, 4, 5.
I think you listed too many.
0, 1, 2, 3.
0, 1, 2, 3. You look at the 10 spots on your data. We have something with a 0 in the 10 spot, the 9. Something with a 1 in the 10 spot, the 2 in the 10 spot, the 3 in the 10 spot, but past that we don't need.
It's like
So for example, at the 0, what are my leaves going to be at 0? 9. That's the only one. What are my leaves going to be at 1?
6.
4,
Four.
6, 9, 9.
4, 6, 9, 9. Do they have to be in that order?
Yeah.
Yes, they must go from small to big. Everybody feel okay about stem plotting now? I didn't write it down, but we talked through it. I think we did it yesterday or the last time. Find the mean amount of fat for those sandwiches. Ooh, hold on. I think that's not right though. Do what?
Clear. How do I input that in my calculator? You just put all the chicken, like the ones that are chicken sandwiches, in one row?
No, you just put it all in one data set.
Oh, do they really have all these sandwiches at the
Well, at one point they did.
19.
You guys feeling better about using your calculator here on doing this stuff? Super useful. You need to get good at it. Get to know your calculator. Take it out to like a romantic dinner. Pull out its chair. Order it something nice. You know, laugh at its jokes. Compliment its hair.
Oh.
Your calculator. Getting to know it.
Oh.
Like a first date, you know?
You take your calculator up to dinner?
Absolutely.
That's what I do.
It was before I met her.
You really know. Oh my god. Yeah.
Now you're all thinking, is this true or not? I don't know.
I'm kind of concerned.
All right. Part C says to find the median. Well, shoot. Already got it. Just scroll down and pull it off my one variable stats when I did the first time. Sweet. Part D says the premium crispy chicken club sandwich, that's a mouthful, is a potential outlier. How much does this one sandwich change the mean? So what I'll do is I'll just go into my data and I'm just going to delete out that 33 that corresponds to that pesky crispy chicken club sandwich. And then
I want it to leave.
you just move your cursor on it and press the delete button.
I hit clear.
Okay, if you press clear and enter, I think it'll be okay also. So if I redo that, look, the mean has gone down to 18.25 by removing that 33, but the median still stayed the same. It's still 19. Are we surprised by that? We shouldn't, because we know in a skewed distribution, the mean is affected much more than the median. In this case, the median wasn't affected at all by the removal of the skew in our distribution. Everybody's cool? Okay. That's it for our first set of 7.3 stuff. We got to finish our other section of 7.3 notes, though. Last time we talked about measures of center, like mean, median, and mode. Today we're going to talk about measures of spread or dispersion. We can use those two terms interchangeably. So our first measurement of dispersion we're going to talk about is called the range. So the measurement of dispersion or spread basically is just describing like how spread out our data is. Is it clumped tightly together, or is it kind of amorphously spread out along a large range of values? To calculate the range, we just range our observations from smallest to biggest. We find the minimum value, aka Q0. We find the maximum value, aka Q4, and we subtract them. In practice, how would we do this? Type the data set into our calculator, do the one variable stats, and then I hate to break this to you guys, you're going to have to do the subtraction on your own. You can type it in the calculator, but the calculator won't give you the range for you. You have to actually type in the subtraction for yourself. Bummer! But I think you can subtract two numbers. And it's an easy formula to remember. Just biggest minus smallest. Woo! You probably don't even need your calculator to find the biggest and smallest. But if the data's not arranged and you got to do other stuff with it anyway, I would just, might as well. You know what I mean? If I got to find the mean later on, the calculator do all the hunting for me. Another measure of dispersion is called the interquartile range. We abbreviate that as IQR. I will probably never write out the words interquartile range. I will just always write the letters IQR. So this is another measurement of dispersion. We'll also use it to classify outliers. So to get the IQR, the first thing I need to do is calculate the quartiles. So I'll arrange the observations in increasing order, locate the median. Then to find the first quartile, I'll look at the median of the observations to the left of the median. And to find the third quartile, look at the median of the observations to the right of the median. And then the interquartile range is just Q3 minus Q1. In practice, how would we do this? Type the data into our calculator, do the one variable stats, and just pull our Q3 and Q1 from the calculator. I would not recommend sorting the data and like mucking through finding, three medians. Yuckarooski. I'll just let the calculator get it for me. Everybody cool? Yes?
So 2 and 3 are just saying that you find like the 1 and 3 and then just subtract them?
Yeah. So let's take a look at an example. Here's a data set. These are the commute times from some New Yorkers. So first thing we do, well, let's sort it from biggest to smallest. And then I'm going to locate my median, which would have been between 20 and 25. So the median was 22.5. So if I look at this set of numbers that are less than 22.5, these two 15s are my Q1. So I average them. If I do the same thing for above 22.5, there's 4 here and then the 4 there. So the 2 in the middle are 40 and 45. I average those. That's 42.5. Yes. Sure. And then to calculate the IQR, I just do 42.5 minus 15 to get 27.5. No big deal, right? In practice, just type the data in your calculator and let the calculator handle the Q1 and Q3 part. Okay, so we can use the IQR to identify outliers. The rule is if an observation falls 1.5 times the IQR below Q1 or above Q3, we can classify it as an outlier. So in our previous problem, our Q1 was 15. Our Q3 was 42.5, and our IQR was 27.5. So to check for outliers, I'm going to do Q1, 15, minus 1.5 times our IQR, 27.5. When I do that, I get negative 26.5. Well, our data is about time. Clearly, there's nobody having negative commute time. So there's no outliers that are too small for the data set, which is not surprising. When I looked at the data set, there were lots of 5 and 10-minute commuters on there. If I do the above, I'll do Q3 plus 1.5 times IQR, and I get 83.75. If I go back and I look at my data set, I notice there is one person, that poor sucker, with an 85-minute average commute. Must live in Connecticut or something. That would be considered an outlier since it's bigger than 1.5 times the IQR above Q3. Everybody's okay? This will certainly be a test quiz question asking you to check if something's an outlier or not. You absolutely need to know how to do that. But it's pretty easy, right? Like the calculator will handle all the hard parts. I just have to check. Can you have multiple outliers? Yeah, right? Okay. Okay, and there's my outlier. So again, the 5-number summary. Again, we've mentioned this before, Q0, Q1, Q2, Q3, Q4. We just labeled Q0 as the minimum, Q2 as the median, and Q4 as the maximum. NBD. One nice visual representation, a way we can graph a distribution based on its 5-number summary, is called a box and whisker plot. So to make that box plot, we use these two terms interchangeably. Box plot and box and whisker plot mean the same thing. To do this, we draw a central box from the first quartile to the third quartile. So like we have like a number line, and we start and we make our box using Q1 to Q3. I don't know why that matters, but sometimes hitting the desk seems like it kicks it back in. Then we draw a line through the box where the median is. And then we draw a line, that's our whisker, out to the min and max values that are not outliers. The outliers we mark with like a special mark, like an asterisk or a star or something. Everybody's cool? So far, so good? Let's do an example, yeah? So, we're going to use that same New Yorker's data. Here's our 5-number summary that we would have gotten from our calculator. I'll start by drawing out a number line. For my box, I'm going to start at 15. And I'm going to draw all the way out to like 42.5 and draw a box. And in the middle of that box at 22.5, I'm going to put a line for the median. Everybody feel good? Now I'm going to draw my first whisker down to the minimum, that's 5. For my second whisker, I'm only going to draw out to 65. I'm not including 85, even though it's the maximum, because we found it was an outlier earlier. So when I plot 85, I'll just plot it with its own special symbol, star, a circle, an asterisk, whatever. What do you guys think? Is this okay? That's how you do a box and whisker plot. Easy peasy, right? All right. And so our second measurement of spread that we have is called the standard deviation. And that's basically looking at the average distance of each observation from the mean of that data set. So let's say we have this data set, the number of pets from a group of 9 people. Oh, 9 children even. I feel bad for the dad out here that has to take care of 9 pets. Because you know that's what happened. The kid asks for the pet, and who takes care of the dog or the cat or whatever? Dad. Dad walks it. Dad cleans the litter box, picks up the poop in the backyard. It's a lot of poop to pick up if you got 9 dogs. Ay caramba. All right. So to calculate a standard deviation, we're going to start by calculating the mean for the data set. Then we're going to calculate each deviation. That's the distance from an observation to the mean. In this problem, the mean is 5. So like, for example, the first deviation would be the distance from 1 to the mean. So 1 minus 5, that's -4. Another deviation would be the distance from, say, the mean to this observation 8. So 8 minus 5, that deviation would be 3. Notice the deviations can be positive or negative. That's fine. Everybody's okay so far? We're going to do that for every observation in our data set. So this is me just writing that down. So the xi's are my observations, right? I have 1, 3, 4, 4, 4, 5, 7, 8, 9. And the mean we said was 5 already, so I just have 1 minus 5, 3 minus 5, etc. After I have the deviations, I square them. Everybody's okay there? After I've squared them, I'm going to find the average of those squares. So I'm going to add these all up and divide by 9. That number is called the variance. And then if I square root the variance, I get the standard deviation. Everybody okay with what we've done here? We'll show you how to calculate this in practice here in a minute when we do our in-class examples. Okay. So the symbol we use for the standard deviation is this sigma, and then usually we put a subscript of an x on it, particularly when we start working with bivariate data sets where there's like an x variable and a y variable, because we'll get a standard deviation for both. So the formula for standard deviation and variance are given here. Now there's actually 2 different types of standard deviation. There's a population standard deviation. That's what we've written down. There's also a sample standard deviation. In IB land, when they say standard deviation, they always mean population standard deviation. They're never going to ask you for a sample standard deviation. The only difference is it's n-1. But you don't care about that. We're never going to use that in this class. Deal? I think that's a good deal. Now, I wrote these 2 formulas down here. In practice, are we really going to use these formulas? No. What are we going to have? What are we going to do? Just going to let the calculator kind of handle this for me. So I'll show you kind of two ways of doing that here in a moment. And again, these are the population versions. These are the only versions that the IB is going to ask about or care about. These are the only versions you should care about, as long as you're in the context of this room B11 in between the start and end of third period. Outside of that, you may care about the samples, standard deviation as much as you want. All right. So now, just like before, when we talked about center, we had two different measurements. We had, means and medians. We have kind of two different measures of spread. We have ranges and IQRs, also kind of a range, and then standard deviation. Remember, the rules for deciding whether I wanted a mean or a median. Means are for symmetric distributions with no outliers. Medians are for skewed distributions or distributions with outliers. The same rule applies for standard deviation. That goes with means. Ranges go with medians. So if your distribution has outliers or is skewed, you should use a standard deviation instead of a range. Or if you're... no, I said that wrong, didn't I? I think that's middle school.
Middle school?
Or the end of lunch or something. I don't know. Hold on. Yes. Sure. Sorry. If you skewed or outliers, you spread. Symmetric, no outliers. Did I say... I can't get this right. Let me slow down. Yes. Here, it'll just come up here. So median is for skewed data and outliers, so we use IQR with that. Mean and standard deviation only for symmetric with no outliers. Okay? I will try to trick you with that and ask you for, what's the spread for this? And you might have to be real careful about whether the distribution is skewed or symmetric or got outliers in it before you think about how to answer that. I might not ask you for the one that I want. I might make you look at the data and know which one you want. I know. That's hard. What if we have to do a transformation of data? So let's say that I was collecting some data and I collected a bunch of temperatures in Celsius. And then, oops-a-daisy, I meet with my research partner. He's like, I need those in kelvins. So I have to add 273 to all of my observations. But I already did all my statistics. Oh, does that mean I have to go back and redo my statistics? Not really. So if I'm adding or subtracting a constant to my data set, that's going to add that constant also to the measures of center. So means or medians will shift. Your measures of spread will not, because your data set, if it's like here to here, if we add the same amount to everything, just going to move over. Did it spread out at all? No, man, it's just in a new location. Everybody's cool with that? So all of your measures of center, your mean, median, quartiles, percentiles, all that jazz is shifted by that same constant. But your measures of spread, your range, your IQR, your standard deviation, they don't budge. Everybody's cool? All right, pretend I'm a researcher and I'm measuring heights of things. I measured all these heights of people in inches. I did all my statistics. And I get together with my research partner who did the same thing, but he's in England, and he measured them all in meters. We got to convert. To do that conversions, what are we going to have to do? Multiply, right? So let's look at the effect of having to multiply. I have an example here. Look, here's my data set. I added something to it. Look at that. It's like the same shape. It's just a new location. Shocking, we just said this. So look, all the things that were location-based, they all moved, but the things that are spread-based, they all stayed the same. Oh my gosh! This was a skewed distribution, absolutely. Skewed right, because it tails to the right. Potential outliers here also, I would guess, but certainly skewed. Okay, what if we have to multiply by a constant? Well, to find my new measures of center, I just multiply by that same constant. And guess what? That constant also affected the spread. So I multiply my spread by that same constant. So again, think about it. If you multiply everything by, a constant, if the data looked, was from like here to here, and you multiply it by 2, it's going to be like twice as wide, right? So the spread should change. However, the shape of our distribution will not. If it was symmetric before, it'll be symmetric after. If it's skewed before, it'll be skewed after. But how much stretched out it is, that can change. So here we go. Look at this. We started with this. We multiplied out. And look, locations changed and the spreadness changed, right? It got a lot wider. Oops. So if I look at the before and then the after, look, oh my gosh, everything got like multiplied by 3. Whoa! Does everybody feel okay? Okay. Let's look at the in-class examples for this. All right. So it says below is a list containing the amount of fat in grams for 12 different McDonald's beef sandwiches. Find and interpret the IQR for this. So in practice, I am not doing that by hand. What? What's my problem? Oh. Okay. Fine. So I did that. And I have Q1 or Q3 is 29, Q1 is 21, so my IQR should be 8, which tells me that like the middle 50% of McDonald's sandwiches are all within like 8 grams of fat of one another. Everybody's okay with that? The distribution from Q1 to Q3 is 50% of it, right? Because they're 2 quartiles. That's the range, not the IQR. So this asks for the interquartile range. Okay. Q3 minus Q1.
Oh.
Not much of a formula. Determine if there's any outliers for the list. Okay. Well, my Q1 was 21, and then plus 1.5 times my IQR, which was 8. Oops, I meant minus. Yeep. Okay. 9. Do I have any observations less than 9? No. Notice I have one equal to 9, but it's got to be less to be an outlier. This is as far out as you could get without being an outlier, but it made it. So no outliers below. Now I have to do the Q3, that was 29, plus 1.5 times IQR. That I get 41. I do have an observation bigger than 41. It is the 43. That is an outlier. Everybody's cool?
So if you get a number
outliers, it's less than the range of your data set, it's an outlier.
So if it's less than Q1 minus 1.5 IQR, it's an outlier. Or if it's bigger than Q3 plus 1.5 times IQR, it's an outlier. So you can have outliers that are too small, and you can have outliers that are too big, right? So it's either less than Q1, those would be too small, or bigger than Q3. You know what I mean? Okay. Here's our same set of fatty McDonald's sandwiches, that 43-gram fat sandwich. What do you think that one is? I bet, well, it says they're beef. I bet it's like the double quarter pounder or something. That sounds like it's packing in the saturated fats there. It's got all that extra slices of cheese on there. Anyways, I'm getting hungry now just talking about it. So it says the 5-number summary. Well, that's easy, right? That just comes from doing our one variable stats. And then it asks to describe the overall distribution, the SOC-S. Who remembers what that first S stands for? Shape. Excellent. Look at this data set. What does the shape appear to be? You could make a dot plot if you needed to look at it, right? That would be the plot that I would use. It's going to be pretty symmetric looking if you plot it out. It's not too bad. You know, most of it's right in the 20s here, and then like it tails off a little bit in each direction, but pretty symmetric. What does the O stand for? Outliers. Were there any of those? We have one outlier at 43. Everybody agree? What does the C stand for? Center. How should I report the center for this? Median. Why the median? Because it has an outlier. Because it's an outlier. Even though the distribution is symmetric, it has an outlier, so I need to use median. Then you would use mean. Symmetric with no outliers, mean. Otherwise, median. So the median here was 26. I just write that. The last S stands for spread. What should I use to report the spread? Range and IQR. Very good. The IQR we already stated was 8, and the range here would be 43 minus 9.
What's the other option to range?
Standard deviation.
And so you would use standard deviation.
Symmetric with no outliers. Same rules for mean. Mean and standard deviation go together. Median and range go together. That's the way to remember it. They're kind of married. All right. Below is a list containing the number of home runs that Hank Aaron hit in each of his 23 seasons playing Major League Baseball. Find the 5-number summary for the list above and then use that to make a box and whisker plot. Ooh, Mr. Kulik. So exotic. Hank Aaron. Any baseball fans in the room? All right, so to do this, I'm going to draw a number line and label it. Now, technically speaking, before I start doing this one, I should check for one thing. What one thing should I be checking for before I really get started? Outliers, excellent. Now, look at this data. I have a 10, a 12, and a 13 all on the low end. And then I have a 45, a 44, a 44, a 44, a 44, a 47 on the high end. Do you think there's any outliers here? Heck to the no, right? You have a lot of stuff that's pretty small. You got a lot of stuff that's really big. I highly doubt there's going to be any outliers. I can pretty much look at it and tell. You should check, though. All right. To do my box and whisker plot, my Q1 is at 26. And then my Q3 is at 44. And a lot of times I'll do this when I'm doing it in practice if I'm writing it by hand. The median is 34, so I'll put a line there at 34. My left whisker goes down to 10. And my right whisker goes up to 47. I like to write a label on all those points just for if somebody's grading this, it makes it really easy for them to grade. Absolutely. What do you guys think on your box and whiskeys?
How do you figure out the lines?
So they're just the quartiles.
Oh,
So 10, 26, 34, 44, 77. The only exception is if you have an outlier, which we didn't in this case. But we saw how to handle that earlier, right? But it's just the quartiles. All right. It says use the data above to construct a table to find the variance and standard deviation for the number of students in the 7 different classrooms. So I'm going to imagine that we are going to fill out a table like we did in the notes when I did the standard deviation variance. So I'm going to show you how to do that with your calculator to make that same table we had in the notes in case, hint, hint, somebody asks you to do a similar thing on a quiz or a test. So I'm going to start by entering in that data just into a list. I did mine in list F. I had to rename and make a whole bunch of new lists for myself, but now in my next list, I'm going to call that list G. I'm going to calculate the deviations. So to do that, I'm going to move my cursor up so it's on the name of the list. See it up there? And I'm going to press enter. Oh, nope, sorry, I have to do something first. Before I do this, I need to do the one variable stats on this list F. My apologies, because I need the mean to do this. So there's the mean. Now, this mean is convenient. It's a whole number. It's 24. If it's some kooky decimal, though, I want to make sure I take all the decimal points with it. To make that easier, I'm going to show you how to do that. So if I go back here to my list G, and I go up to the title, and I press enter, you see my cursor flashing here, G equals. What I want to do is I want to take my list F, so I can press second and list, and I just scroll down and find my list F, or you can use L1, L2, L3, etc. And I'm going to do minus X bar. Let me show you where the X bar is living at. If I press vars and then go down to stats, X bar is right there, option number 2. And then if I press enter, whoop, populates the whole list for me. Now keep in mind, you had to have done the one variable stats using that data set so that the value for the mean was stored into X bar. Right? You have to do that first. All right, for list H, that needs to be list G squared. So I'm going to do the same thing. I'm move my cursor up onto list H, press enter to get my cursor flashing down here, H equals. And I'm going to go second stat. I'm going to click list G, and then I'm going to say square it. And then press enter, and whoop, populates that down for me. Everybody feel good? Okay? And now, to get the variance, all I need is the average of list H. So I'm just going to do my one variable stats on list H. So there's my variance, that 5.4. So if I take the square root of my new x bar, that'll give me my standard deviation. I can't remember what's on the activity. If I ask you to do this on the next activity or not. I tend to think I did, but. Now, Mr. Kulik, couldn't I have just done like the one variable stats on the on my original list? And isn't that sigma x just the same thing and what you ended up with? Yeah, it is. It is. So in practice, if you just need a standard deviation, am I doing it by hand with like a table on my calculator? No, I'm just going to ask for the one variable stats and take it. For the record, the SX, that's the sample standard deviation. That's the one you never want for this class. And I want to point out to you, if I wanted to now recover the variance, I can just take that sigma x and square it. So I do vars statistics sigma x and then squared. Whoop, there's the variance for me. I can recover the variance from the standard deviation just by squaring it, which is super nice. How we doing so far? It's all right. This is the same thing again. Why don't we try, once you guys try doing this on your own, and we'll see if you guys can work out to the same thing that I get. Sound good? I'm going to do it alongside you. But to pick. That's what I want. So that should be your variance and standard deviation at the end. I'm ripping through because it's the end. I'm going to put in the answers for all the in-class examples if you want to go through stuff again. So you can see like intermediate, like what I did and what the steps were again and what the calculator had. But that should be something you feel comfortable doing in like a quiz or test setting. Sure thing, dude. See, I have all this stuff up. Yeah. Why don't you just take like a picture of this front page and you can just use the same data set that Fran did. You can sit on a table or something so you get a decent picture out of it. Yep, that's all you need. So it was like we surveyed our classmates, some of our classmates about.
The questions are, do you have access to that?
Oh.
Or... Sorry, thank you.
Here's a,
Thank you so much.
yeah, you want to staple that. There's a stapler there. Make that life a little bit easier than having to worry about keeping track of it all. Are you feeling better?
For the most part,